Hey guys, and welcome back to part 6 of my tutorial series on React Redux and Webpack. If you've actually watched all of this, congratulations. You've watched at least a couple hours of me drawing and coding. That's impressive. Now, when we left off last time, in part 5, we had learned how to handle data in the state of a component and then pass that state down as props to the child components. Now, I think the next step in the evolution of learning how to use React is Flux. I'm sure you've heard it. Redux is what I will be talking about. Redux is an implementation of Flux, and it's a method and a way of handling the state, the data of an application. And you might say, is it necessary? That might be one of your questions. Is it necessary to learn it? And in fact, I worked with some groups of engineers who were starting out and learning how to use React and learning how to build their app in React. And ultimately, they did decide that because of their time constraints, it was not beneficial for them to spend time learning Flux, and that they would handle the state on their components in no special way, just use React to handle state and pass it down as props. Ultimately, after they were done with their project, they realized that they probably should have used Flux or Redux specifically from the start, because you're almost always going to run into an issue with an app of any kind of complexity where Flux will help you. It'll help you reason about your data, it'll help you debug your app, etc. So I don't want to spend too much time building a so-called, vanilla React app. But I think it will be useful to go through a little bit and add some complexity to this kind of contrived app we have going on here, and to show you some of the pain points and why you may not want to use vanilla React and you may want to supplement it with Flux, with an implementation of Flux. And ultimately, if you're going to do that, you might as well just use Redux, and we'll definitely get into that. So let's see, do we have our server up and running? Let's clear this crap. So here we are. We've got our input. When we type into it, it passes it down as a prop to the text display element that is its child. The text display element displays the text. Now, let's add a little bit of complexity. Let's say we want the text display element, which again is a child of this larger. So here's the text input. And then within text input, we have text display. Let's say we want text display to be able to have a button where it deletes one letter from the input. Sounds simple enough, right? So how would we do that? Well, we can go into our code. Am I on the right branch? Nope, that's not what I wanted. So our text display component is here. Let's make this a little bit more complicated of a component. We'll enclose everything in a div. Close out that div. Close out that parentheses. Again, these parentheses are just because we're going to a separate line under the return keyword. Let's add a button. Let's call this button delete one letter. Very, very creative name. Let's save that. What is this? Nothing. Cool. We got a old school looking button here. Doesn't do anything. We can click it, but it doesn't do anything. That's good. So let's add an onClick handler, and let's set up a function that we're going to call handleClick. And this function will be on this text display element component. Click. Okay, so what are we going to do? How do we change the state, which is coming from the parent component text input? How do we go about changing the state? Well, what you can do is you can have a function here on text input which has access to the state. You only have access to state on the component that you're keeping track of state on. So we'll have a function on this component that can delete a letter from the input text. So let's do that right now. Let's call this delete letter. Seems like a pretty valid name to me. What delete letter is going to do is we want to take current this dot state dot input text, and we want to delete letter, and we want to update state. Cool. So how can we do that? Well, again, to change, anytime you change state, you want to use this dot set state. So we want to this dot set state. We want to update the input text. And what do we want it to do? Well, when we're calling this function, it hasn't changed yet, so we still have access to what the current state is. So what we have access to this. This is what the current input text is. And what we want to do is we want to substring this, and I think this probably just takes, so substring, let's check this. W3 schools is, it's all right. So it looks like we give it a start, which will be 0, and then we want to end it 1 before the length. So it looks like it's really not inclusive. So our index is 0 base, so our last index of the string is going to be length of the string minus 1, and I think that's what we pass in as the end, and it won't include it. So the index that we specify will be the first character not to be included in the return string. So we do this dot state dot input text dot length minus 1. So our first value here is 0. We start at the start of the string and we go to the length of the string minus 1. Cool. So delete letter will delete that for us. But remember, the only time we want to delete a letter is with the button on the child component text display. So how is the child component going to have access to this method, which is on the text input component? Well, I'll give you 2 seconds to think about it. State and props. So we have access to props. We can pass something down to text display as a prop. And the props don't have to be just strings. In this case, state.input text is a string, but they can also be functions. So we can make a prop and we can call it whatever we want. I'm just going to call it delete letter. I'll keep it the same name so we know what we're doing. And this is going to be equal to this dot delete letter. Save that. So if we go to our app now, let's save text display. Not sure what we changed. We just added this handle click function, but we're not doing anything. Let's just log button clicked. Make sure we got everything working. So we go back to our app. Let's go to our console. Oh, cool. Button clicked. The button clicked is working. Let's see if our delete letter function is coming through. Oh, there it is. So here we have the text display function, and it has a prop, and it's a method. It's a, yeah, that's what we want. It's a method. So now within this component, we have access to this .props.deleteLetter, and that's a function. So basically what I want to do is anytime we click on this button, I want to call this .props.deleteLetter. Save that. It's not working. We're getting an error. So we saw this in our last video. This onClick is an event handler on an HTML element. Well, ultimately it comes from an HTML element on the page, and so we have to bind to this so that the handle click function has access to this component and not the HTML page where it's actually originating from. Let's see what happens now. Okay, so now we are seeing an error in the text input, so the parent component. And what it says is, it cannot read property input text if undefined. So this is a similar problem to what we just saw. The text input, which is the parent component, is passing down this, this method. This method ultimately wants to change the state, this .setState, on this text input component. Yet when it's actually getting called, it's getting called here in text display. So the this that we want it to be is not occurring. Let's log this. Because this function is getting called, handle click is getting called in text display, this is getting assigned to text display and not text input. So like we see here with the bind, we can do the same thing with text input. When we pass down delete letter as a prop, we can bind this. So now the this will be hopefully this that originates here in text input. We'll go back to text display, get rid of this, uncomment that, save it. Let's see what happens. Boom, there you go. We click it and a letter goes away. So as you can see, without any special systems in place for handling state and data, when you do want to change state in a parent component or another component, you can pass down functions. This is almost like a callback style of doing it. We're kind of passing down a function called delete letter down to children components, and then they'll call that function when they want to update something up here in the parent component. There's many reasons why you don't want to do this, and I don't know all of them, nor do I want to talk about all of the ones I do know. But what this does lead to is kind of a bi-directional data flow. So now we have children components. We have children components changing the state on parent components, which are sending props down to children components. And if you'll recall back from one of my first videos when I showed you the typical model view pattern and the kind of circular dependencies that happen with bi-directional data flow, that can start happening. It gets both confusing for the developer and it gets harder to track down bugs for the developer. And so this is not the best way to do it. The better way to do it would be to handle all changes in a separate location you can think of this location as being above all of the components. And then all of the data and all of the state always flows downward. It always flows unidirectionally. And you'll hear people talk a lot about that with React. And because of this, Facebook kind of came up with this different type of architecture of handling state and handling data. And they called it Flux. And so this is probably actually a good time to get the iPad back out. Give me 1 second here. So Facebook came up with Flux, and this is not a library, this is not a specific framework. It's more of a general architectural pattern for setting up your application, and it works really nicely with React. Because React handles passing down data in one direction really well, if you can manage all of your data in this way, it keeps all of your arrows pointing in one direction, and trust me, it keeps your mental model around the app much simpler. And because of that, it allows you to add components, rework components, change components in a much easier way. So what is Flux? There's this diagram you always see, and I probably could just pull it up, but instead I want to be fancy and kind of draw it out. So we have a store. The store holds your state. We'll get into the specifics of what a store is, and we'll get into all these specifics much more. But that's your store, and then basically the store, you know what, I want to move this. I want to move this over here. It's unidirectional, so basically it kind of creates like a circle. Ultimately, the store holds all the state, so the components don't hold state anymore. They can in specific instances, and you may want them to. But if you have data that is kind of app-wide, so multiple aspects or multiple parts of your app might want to see this data, change this data, display this data, then you keep that state in a store, and this store passes it down into your components. And I'm just going to draw one box, but you know, this is a whole tree of components. And once they get state as a prop, they can then pass it down to their children and so on and so forth. Now, of course, this is all well and dandy, but ultimately, like we saw in this last example where we wanted to change the state from either change the state of a parent component or change the state of a sibling component, whatever you want to do, you'd have to do some finagling with callback functions and passing functions down as props and what have you. But of course, we need ways to change this data. So how do we do it? Well, what we do is components then are either listening to user input or getting data from a server or whatever occurs that needs to change the state, we fire an action. So there's actions. There's actions that can change the state. This action could be delete a letter. Done. Pretty easy. They're very simple actions. Add a to-do, delete a to-do, edit to-do, all this stuff. Actions generally have some type of type property that like add to do. So you know what action it is, and then it'll have the data or the payload. So it'll have the actual to do, the text or the date or whatever it is, or both. Wow, that's incomprehensible. Anyway, once you have an action, the actions get passed to what's known as a dispatcher. And I'm not going to get too much into the details of all this right now, but the dispatcher just takes in all the actions and kind of is the gatekeeper to the store. And one at a time, it'll send these actions to the store. The actions ultimately update the store. And we'll see with Redux specifically how this happens, but in different implementations of Flux, there are different types of functions that take in an action and update the state. So in the case of the add to do, there's probably an array of to-dos, and it adds one on the end. Once this is updated, the components that need to know about the state or that specific part of the state, in this case the array of to-dos, will hear about it, state passes it down, and boom, you get your React magic. Components will then see what needs to be, the React will see what needs to be different, update the DOM on the page, pass it down to child components, etc. So as you can see, it's unidirectional. Everything flows in one way, and none of these arrows are flowing back up. Nope. Get rid of those. They are flowing into the actions, which are then coming back around and changing the state. Now I'm not going to get too into it right now, but usually in your actions you're making server calls if you have to, and getting data or updating data on the server or the database as needed. So this is kind of your general Flux outline. We saw, I guess I want to add one more thing, is that the example I started doing right before I went into this drawing was I was showing you how to change the state of a parent component, you have to kind of send down a function, a callback style function that gets invoked and changes something in a parent component. Another issue with not keeping your data in a centralized store is that if you need to change the structure of your app or how the components are in their tree, you might have to change a lot about how, which functions you're passing down as props into different components. Or let's say, let's get a new thing here. Let's say we have our text input, and a child of the text input is our text display. This is what we were doing before. Now we're holding the state here, the information that we're passing down. But what if all of a sudden our app component is encompassing everything, if you'll recall. So here's the app component. What if there's a sibling component to text input called header? And what if we want to display something? What I'm thinking about is Facebook's little you have 2 unread messages or whatever. I don't even know what I was drawing there. Say it's an envelope. And you have 2 unread or something. So in this case, the state would be the number of unread messages or the actual messages, and we want to know something about that state in the header. But all of a sudden, now we're keeping track of state here, and this really means that because of the kind of general paradigm of React, we want state to be above both the header and text input and text display. And so we actually want this state to be held in app. But the problem is all our logic for changing state is here in text input. It's not in app. And so we would have to move the state, which isn't that hard, but we'd also have to move all the functions that are updating state. And then we'd have to make sure those functions that we move to app are being passed down into header, and then into here, and then into here. And so we actually have to re-architect a lot of our app. The alternative is, let's just get rid of a bunch of this crap. Boy, I just draw a lot of lines sometimes. The alternative, the alternative is not to keep state here, and not even in app, but yeah, this sucks. The alternative is to keep it in its own system. So keep it in a Flux type system. And if we do that, we then keep our state in a store. And if header, so our state is here. So when we first wrote our app, cool, text input gets it, and then text input throws it down here. And then all of a sudden we realize we want to show some data in the header. Well, that's easy. Just hook up the header to the state and it'll be notified whenever it updates as well. And if we add another component some other time in some other spot in our app that's in a total different branch of this tree, whoops, what is that? No problem, hook up state. Hook it up to the store and pass it in the state. And remember, if we need to change something about the state, we fire an action that gets dispatched to the store. So if this component needs to do that same action, you don't have to rewrite the function, you don't have to find a way to pass it up and back over to the tree. No problem. You just fire that action and it'll update the state, and everything that needs it will get updated just fine. Cool, so I drew a lot of squiggly lines, and hopefully I didn't confuse you even more than you've probably already been confused by me. But I hope this gives you an idea of why you'd want to use Flux, and ultimately from here on out we're going to be implementing Flux and we're going to be using it. I think one of the coolest libraries out there, and you've probably heard about it if you are reading about React or interested in it, is Redux. And I think although there's a bit of a learning curve, I hope to just totally annihilate that learning curve for you so it becomes super easy to understand and super easy to implement. And that'll be in the next video. I'll do probably one of these little diagram sessions where we talk about what Redux is. And then in the video after that, we'll actually add Redux and we'll make our app look a little bit more like a to-do app. So until then, happy coding and see you soon.